Assalamu alaikum students. Now we will discuss about reaction of aldehyde with HCN. It's a hydrogen cyanide, is an acid, and it will dissociate into H positive ion and cyanide ion. How it will react with aldehyde, that can be demonstrated over some examples like double bond oxygen H and R. You can take any R group over here plus HCN, right? It will react with aldehyde. This is partial negative, this is partial positive. So negative will take this hydrogen and positive will take this cyanide ion over this. So the product must be R C OH H C triple bond N. So oxygen ने hydrogen खींचने, this is positive, this is negative. So negative will over there and this will go to there, right? How this section have certain steps in the form of mechanism. Now we will discuss its mechanism of addition of HCN in aldehyde or ketones. How it works? Let's explain with mechanism. Right. Initially, we have this aldehyde R H reacting with H C triple bond hydrogen cyanide. इसमें negative part is CN. The CN will goes to this partial negative and this is partial positive. This negative will goes to positive center, and this pair of pi electrons will shift over oxygen. जब shifting होगी, R as it is, C as it is, H as it is, attacking substance is Cn. This become negative, right? So this negative will be shown as O negative, right? This is Cn. This negative will attack on this partial positive carbon, and this partial positive carbon, the pi bond will shift towards oxygen. Plus here H positive ion, remaining this H positive ions. Now the second step, these two will recombine to form this negative will take this hydrogen. Very simple mechanism. R as it is, C, it becomes OH. H as it is, C triple bond N. This is a mechanism of addition of HCN in aldehydes, right? Okay, next we will discuss reaction of aldehyde with water, with H2. Probably I'm sprays this one. This one is reaction with water. It will form hydrates, right? It will form hydrates. Formation of hydrate with the aldehyde will be demonstrated with this chemical equation. Like we have compound R C triple bond oxygen R, right? So this is your ketone. You can take any alkyl group, replacing R with CH3, alkyl, ethyl, propyl, butyl, anything, right? But already know this is partial negative, this is partial positive side, right? This will react with HOH. HOH means water molecules in the presence of acidic conditions. This negative will take this hydrogen and this negative will goes to this carbon. दोनों reaction में same rule होती है. R C R O become OH and remaining OH is attached over here. This is example of hydride formation. Right. This is your acid condition. The mechanism of this reaction will be of certain steps. Right, we have starts with reaction of aldehyde or ketones, properly aldehyde ketones, with acid. In this case, we have you can use any acid like CH3, oxygen, CH3, HBr, hydrogen bromide. You can use HCl, you can use HF, you can use hydrogen iodide, but HBr must be the most proper acid we use in this section. So initially, again, we know this partial positive and this is partial positive carbon. This oxygen by using this two lone pair, one of lone pair is being used by the formation of bond between O and H, and this pair of electron will shift over bromine as bromide ion. So CH3, CH3, double bond oxygen, H. We have two lone pairs over there, but in this case we have only one lone pair over oxygen, so it becomes positive plus bromide. In this case, this compound will rearrange into somewhat more stable, because oxygen is most negative element after fluorine, so it must not be positive. अगर ये positive आ गया तो आपको इसका positive charge remove करना है by shifting certain pair of electron towards itself, right? So we will do it like this. This pair of pi electron will shift over this oxygen, right? This oxygen now have two pair of electrons like CH3, C, oxygen, एक पेयर इसका already है, एक pi bond form shift हुआ, and CH3 as it is. Now this carbon is positive. It will react with bromide ion, right? So bromide ion will strong nucleophile. This nucleophile will definitely attacks on. In second case, we have certain water molecules, H2O, HBr basically हमने aqueous form में use किया. So aqueous form में हम water molecule यहाँ पे use करेंगे. So water के पास there are two lone pairs, and these two lone pairs will attack on this partial positive carbon. This is electron rich side and it will move toward electron deficient side. So we have a reaction, CH3, OH remain as it is, CH3 as it is, attacking sub element is oxygen. So oxygen, hydrogen, hydrogen. Again we have a positive charge on this oxygen. Now we have bromide ion. In the last reaction, last step, bromide ion will take this hydrogen and this pair will shift over this oxygen. So we have CH3, CH3, it just OH, and यहाँ पर भी हमारा, right? This is a mechanism of reaction of aldehyde or ketones with water molecules. Okay. Okay. Next we will discuss about oxidation of aldehyde and ketones. So our next topic is oxidation of aldehyde and ketones. We use some oxidizing agents like potassium dichromate in the presence of H2SO4. These two compounds will react to form nascent oxygen, and these nascent oxygen are responsible for oxidation of aldehyde and ketones. The oxidation of aldehyde is somewhat easier, and oxidation of ketone is somewhat difficult. How it is difficult we will explain in the example of ketones. Next, initially we will just take example of aldehydes, in which aldehyde will react with these two compounds. Initially these two compounds will react to form nascent oxygen. Now these two nascent oxygen will react with aldehyde to form carboxylic acid. In both the cases, oxidation of aldehyde and ketones, it will produce carboxylic acid. So first statement you need to memorize is oxidation of aldehyde and ketones in the presence of K2Cr2O7, they will produce carboxylic acids. How it will work? Like double bond oxygen, H, and CH3. Here we have ethanol in the presence of these compounds as reducing agents, and H2SO4, they will produce oxygen, and that oxygen will attach. Now just check how I'm drawing this compound. CH3, as it is, double bond oxygen as it is, and H as it is. There is no difference between these two compounds. The only difference exists is with respect to position of oxygen. Here just we have little oxygen. That oxygen came from direction of K2Cr27 and H2SO4. Right? Similarly, if you have butanol, what must be the product? Just कैसे? This is a homework. अगर यहाँ पे आपका butanol हुआ, that butanol upon oxidation with these two compounds will produce another compound that you need to guess up. Next is oxidation of ketene. That is somewhat difficult, right? Like double bond oxygen, CH3 in the presence of same conditions, K2Cr2O7 H2SO4. हमें इस कार्बोनिल ग्रुप के साइड से, either from this side, either from this side, carbon to carbon bond break करना है, either from this side or either from this side. Here we have same groups on this carbon, around this carbon. Carbonyl group के दोनों साइड पे same group है. That's symmetrical ketones. In case of symmetrical ketones, break that from either side, either from this side, either from this side. No problem at all. Either from this side, either from this side. जब आपने इसको यहाँ से break कर दिया, it become another part and it is your second part. इन दोनों parts के आपने carboxyl कैसे draw करना है? Here we have one carbon, here we have two carbon. Just carbon number 1 and carbon 2. एक साइड पे दो कार्बन बच गए, एक साइड पे सिर्फ एक कार्बन. आपने एक कार्बन वाला कार्बोक्सिल कैसे ड्रॉ करना है? जस्ट नीड टू ड्रॉ कार्बोक्सिल एसिड ऑफ टू कार्बन. डबल बॉन्ड ऑक्सीजन OH and CH. This remaining atoms will be definitely fulfilled. H, double bond oxygen and OH. This is your formic acid and this is your ethanoic acid. In case of unsymmetrical ketones, now unsymmetrical ketones are those ketones which in which carbonyl group have different groups. How groups are different? Like double bond oxygen CH2 and CH3 and we have CH3. इसके सराउंडिंग में कार्बोनिल ग्रुप के सराउंडिंग में एक तरफ मिथाइल एक तरफ इथाइल. सो इसका सिंपल सा रूल ये होगा कि आपको कार्बन टू कार्बन बॉन्ड वहां से ब्रेक करना है दैट कंटेन लीस्ट हाइड्रोजन्स. यहाँ पर 3 हाइड्रोजन है और यहाँ पर 2 हाइड्रोजन. हमें यहाँ से बॉन्ड ब्रेक करना है, राइट? सो एक तरफ 2 कार्बन एंड अदर साइड आल्सो कंटेन 2 कार्बन. अगेन द सेम कंडीशंस वी हैव K2Cr2O7 and H2SO4. 2 कार्बन इस तरफ है, 2 कार्बन इस तरफ. जस्ट ड्रॉ these 2 carbons प्लस and just draw carboxylic acid in each case. Aldehyde की oxidation हो या ketone की oxidation हो, in each case we have carboxylic acid on our product side. Double bond oxygen, OH and CH3, double bond oxygen and OH. Right? These are certain examples of oxidation of aldehyde and ketones. if आपको देते हैं self check, इसको try कीजिएगा homework as a homework. Like we have pentanol, 2 pentanol, right? इसको आप correct करवाएं. K2Cr2O7 H2SO4 and form your product. This is your homework. So students, if you have any confusion about the reaction of aldehyde and ketones, do not hesitate to contact me at any time. Thank you very much. Stay at home, be safe. Assalamu alaikum.